Hi, I've been following along with Paul McWhorter's Raspberry Pi lessons. And to be honest, lesson 12, I just kind of did my own thing on and actually used uh, well, first of all, we were supposed to be uh, lighting up a three-color LED, um, different colors using PWM on the Raspberry Pi to light it up in different colors using three separate buttons. So I kind of just skipped over that and using my PySimple GUI library, I went in and actually used a built-in color picker in Linux to change the color on it. So I really didn't do the homework on it on number 12 the way it was supposed to be done. Laziness on my part, didn't want to wire up the three buttons and the three color LED. But um, anyhow, I enjoy watching other people's homework solutions, and um, Brian is one of the people that post their solutions, and he was asking, what we thought of the way he did it, and um, how we would do it differently and everything. And there's a couple other comments from Charlotte, myself, and Paul, of course, usually puts a comment in, and BBF usually goes in there, and Wendy Grant, she usually looks at them as well. There's several other people there, Itsy, and a couple other ones look at them, but yeah, it's good that we have a group of people to do it. But so I decided to revisit lesson 12, give my take on how I would do this. Um, First of all, a couple things. There is no wrong way to code. I have my own thoughts and everything, but I enjoy watching everybody else. And Brian's code was very easy to follow, and um, got the job done. So I have no problem with that at all. I know Charlotte usually posts pretty good solutions, and she also is using Python on the Raspberry Pi Pico microcontroller and doing a lot of stuff with that. So um, she's going above and beyond as well. And but I try to look at others and see how they do. But since I skipped out on lesson 12, I figure I'd come back to it. Another thing is, I think it's great what Paul is doing, because Paul goes in and gives us a direction to go by, there's so many things you can do on a Raspberry Pi, and he, gives us a foundation. This GPIO library, which is um, new to me, so that was good. And he goes in and tells us, how to read inputs and do outputs and everything like that. But he builds a foundation, but he doesn't necessarily give us all the information. So when I've been following his AI lessons, when he introduces a library or module, whatever they call it in Python, I always try to find the documentation on it and do a little bit more of a deep dive and see what's going on with these libraries. Did the same thing with VPython, and Paul showed us a lot about it, but can't show us everything, and no matter how many videos you make. So anyhow, I noticed that some people are commenting, well, I use different ways of doing things, because but if you go to, all I'm doing is using stuff that's available in the library. So um, one of the things that I do is for inputs, we have the normal where Paul showed us how to test your inputs by polling them every time through the loop and find out whether it's been pressed and if it's a first pressed or whatever. And that's a good way of doing things, but the library also gives us a interrupt and edge detection function that'll allow you to uh, not have to sit and pull the pin all the time. It's going to tell you when it changes. So we have so what I use is this event detection thing. So I encourage anybody that wants to see why I use what I do is to go to this Raspberry Pi, just look up Raspberry Pi GPIO Python library, and this will come up. If I remember, I'll put a link to this library in my video. But it just like I said, Paul lays the foundation, and I try to build on that for what, to find out what I can do better. So anyhow, getting back to what, well, Brian took his, Paul gave us a direction to go, and Brian actually changed it a little bit. So and with Paul's, as you got to the top, you kept hitting the button. When you got to the top, then it would roll over and go back to 0. Brian's idea is to push the button until it got to the top, and then if you keep pushing the button, it starts stepping down, which is pretty good way to do it as well. But and then both Paul and Brian were wanted, we found that the LED reacts better with a logarithmic scale than it does with a linear scale. So we wanted to do it that way. And Brian wanted to be able to dynamically to be able to choose how many steps you wanted to do when you were running your code. So he built that into his solution. So I figured I'd do it. So I guess I'll tell you, I probably have mentioned it before, but my idea when I code is if you have to do anything more than twice, it ought to be in a loop, or it ought to be in a function that you can call. I just don't like to do things more than once if I don't have to. Same way with calculations. If you're going to do the same calculation over and over again, I think that it should be done once and put in a variable or a list, and you can refer to it that way, and you don't have to do the calculation over and over again each time through the loop. So that's pretty much what I have done. So so with Paul, he went through this good long discussion on logs, which I have to tell you, I learned it back in high school, but I need the refresher course, and I appreciate the way he gave the refresher course in there. But I just got this page that he pulled up, and basically what we're doing is you're coming up with that your A, or your number that you're going to use for each power, is going to be 2 over the number of steps, or it's 10 to 2 over the number of steps. So anyhow, let's go to I did start out with code. I did this back when we were doing number 10, because I actually calculated a list of steps for mine, and I didn't actually put this code in my solution for number 10, because I just copied the list, came up with a list, and I copied the list amounts, the values, and put it in my code and just used it as a constant list. So but like I said, Brian wanted to be able to do this as you did the code, change it as when for each time you ran the code. So, but anyhow, this is a dozen lines of code, and we can run this, and I already got it going on where you can put in your number of steps. Let's just do 7 steps, And you can see I start off with 0 because you got to have an off, and you don't logs don't have a 0 in them, so you start off with 0. So if you go through this code here, I'm just inputting, you enter the number of steps you want, just put it in, change it to an int so we can do math on it. And then, like I said, this log constant, which is the base that you're raising to a power, the number of step power. So it's 2 over number of steps, or 10 raised to 2 over the number of steps. And then we're just printing that out. And you can see for 7 that that number underneath is going to be 1.9. And then we just kind of we start a list of log ranges. So we start it with 0 because we want it to always start with an off so we can turn our LEDs off. And then we range, because this is exclusive, you got to do number of steps plus 1, so it does all the number of steps to get up to 100. And we're just looping through it, and we're appending the log constant that we calculated, and we're raising it to the step power. So, and we're just adding that, appending it to the table. And that'll be the first set of numbers here, you see. And instead of doing int, we're doing round. So if you do round and you don't put how many decimal places, it basically rounds it to an integer, but the nearest integer. So 0.6 is not going to be 0, it's going to be 1. So that way you get your 100 every time on your top one, where if you just did int here instead of round, you might end up with a 99 here at the top. So it's going to be close to 100, but it might not be 100. So we did that. And then Brian also wanted to have where we went from 0 to 255, because probably he thinks we're going to need that for future lessons. So I just did that. I did some list comprehension here and just took the list long range, and we're just multiplying it by 2.55 for each item in that list, and we're rounding it to integers, nearest integer as well. And so we get these numbers 0, 5, 10 on up to 255. So you'll be able to get both of those, and then we're just printing them out. So I said, well, I can integrate that into my code that we need to do. So this is the code for lesson 12, and it's doing it the way Brian suggested, where we're going up and then back down instead of rolling over to 0 every time. So again, let's see where I want to start. We'll start down here, GPIO. So this is where we're doing the BCM, and all this we've been doing all along. So, and then here's where I integrated the logarithmic, and we're only doing it one time, and we're creating, I don't even need this for this one, but we're just creating this log range that we're going to be able, a list of numbers that we can access. So and then we'll go back up a little bit. So for, like I said, we're using the GPO rising, the event detect. So we're using the interrupt type thing here. So we don't even have to have a loop, because it's going to create these interrupts, and it's just going to run until we quit the program, which I just have an input to quit the program and clean up the GPIO down here. So yeah, I mean, like I said, go back up to the top here. We're creating a list of pins. This is the LED pins for the RGB. We have a position number, which is the position in the step number in our list that we have. and it's gonna, that number is gonna start at 0, but it can, depending on how many steps we pick down from down the bottom, you know, that's gonna go up to the number of steps. And also I wanted to change direction by using, I use 1 or -1 to increment or decrement our steps each time through. And then this is a list of the buttons. Again, like I said, this is R, G, and B. This is R, G, B for each one of these. So we got 3 in each of those lists there. Now the other list, the log range list, it's going to be bigger. It's going to be variable depending on what size it is down here. Like it's say, you know, you can make it whatever size you want, and it doesn't matter. We're taking the length of it when we figure whether it's time to switch directions on our increment and decrement. So what happens with is that we're creating actually 3 events here, for 1 for each of the button pins, and but it's the same exact thing. It's calling the same exact function, this button press function, and this bounce time, like I say, that debounces it for us. So we actually have three of these events for each pin. So and then what it's going to do is it's going to go up here to this button press, and it's going to send the button number that as a to the function. So it's the number, but we really want to know, to interact with all these other ones, we need to know the index of it. So this function here, you can look up the index of that number in buttons, and it'll give you this index number. I'm calling it color index. And then, like I said, we check to see if we're at the top of the list or the bottom of the list. So we do that. And then we increment or decrement the position, the RGB position of that of whichever RG or B, whichever color we're on. And then we change the duty cycle of it, and we're changing the duty cycle. This tells us whether it's the RGB position or RG or B position, and that position is the index to the log range list. I'm sure that other people might find this confusing, but I really like the idea of using, you know, list and, you know, nesting them and stuff like that. And it seems to be second nature to me, so I don't have a problem with it, where I think a lot of people might have a problem with that. But anyhow, and like I said, every time you press any of the 3 buttons, it's going to run through here, but it's going to act on a different set of values depending on which button is pressed, but it's running the same code. Like I said, you could run this for an R and have this code for an R. We could have this code for a G, and we could have this code for a B, but why do all that when you know what button, when we can index through and know which button and know what position each color has and everything like that. So basically that's all that it has to do. And like I said, it just runs this one time, and then it just creates these events. And while it's doing this input, waiting for this input, it just, anytime an event happens, it just automatically detects it and runs this function up here. And this is where all the action happens. So we're just sitting down here waiting for a cue to quit, and that's all we do. So we can just show it working here a little bit, I guess. Actually, I don't think I quit out of this other program, so I better go back here and quit out of this. This one here, you got to do the Control C to quit. There we go. And now we can go back to this one. So like I say, it ended up being about 35 lines. So my point is that I like to make it work in my mind. And then if it's going to be a serious project or something that I want to remember how I did it, I go through and write lots of comments to tell what I'm doing on each line in case I forget 6 months down the road or whatever. And say, oh, okay, that's what I'm doing that for. So I try to, use lots of comments in my code when I can. So, all right, so we're ready to run this. So let's go up here and run it. Okay, so it wants to know number of steps. So we'll just go 5 steps. Whoops. Yeah, remember to get your cursor down here. 5. All right, so it's actually waiting for Q to quit, but it's also waiting for the interrupts when we hit these button pins. So we can do red. You can see red came on. And it's also printing out the 3 values. So I didn't have a carriage return here, so it's 3, 0, and 0. Hit red again. Now 6, 16, 40, and 100. And then as you keep going, it's going to get dimmer. 40, 16, 6, 3, 0. And again, like I say, green works. And you can do both of them at the same time and have like an orange color, I guess. Yeah. Green. And blue also works. Blue and red makes purple. There's some purple going on there. Back to red. Back to purple. Okay. Anyhow, so that's my code. Definitely, I have a different way of doing it than other people, but I would encourage everybody when Paul gives us a new library to play with or something, go look at the documentation on it and see what else the library can do. Because, Paul, like I say, Paul can't cover everything, and this, for me, this was a great find because, like I said, you don't have to keep track of the buttons, and just makes it work out really well. So anyhow, that's my code. Thanks, Paul, for all you do, and thanks for everybody that posts their code. Brian, that was a great suggestion, and I wanted to follow up on that. Thanks for watching.